Hey guys, I'm going to go through the answer key to that limits mix practice worksheet that I had you work on over the weekend. This is going to go through all the answers and just a quick explanation for each question. I know there were one or two on here that I had a couple of people emailing me about, so I just wanted to make sure I go over all the questions to make sure that you are feeling comfortable with those topics. So question 1 was the limit as x approaches 3 of x squared plus x minus 12 over x squared minus 9. Now, as with every limit that we have, the first thing that we want to do is plug in. All right, so if we plug in the 3 squared is 9 plus 3 minus 12 over 3 squared, which is 9 minus 9. We're going to end up with 0 over 0. So hopefully everybody remembers that when we get 0 over 0, our next step means that we are going to factor. We're going to factor, cancel out any common factors, and then reevaluate our limit. So x squared plus x minus 12 can be factored to x plus 4 times x minus 3. And the denominator is the difference of two perfect squares, so we get x plus 3 times x minus 3. And after we do that, we see that we have a common factor in the numerator and denominator of x minus 3, so those cancel. So now I'm going to reevaluate my limit as x approaches 3 with now our simplified function of x plus 4 over x plus 3. And when I replug in the 3 for my x value, I'm going to end up with 7 over 6 as my final answer. So that's the y value that this function is approaching as our x value gets closer and closer to 3. Moving on. Part B said the limit as x approaches 0 of negative 6x to the 5th divided by x to the 9th. Well, this, again, when we plug in, we get 0 over 0, so we need to factor. Now, not everybody thinks automatically of GCF as you're factoring, but really you have a common term in the numerator, both the numerator and denominator of x values. So if I factor out an x to the 5th from both the numerator and the denominator, right, because x to the 5th times x to the 4th would get me back to that x to the 9th that we had. So I'm just kind of pulling out a GCF here. Those x to the 5ths cancel out, and we're left with negative 6 over 2x to the 4th. So now we are going to reevaluate our limit as x approaches 0 of now this simplified function. And lo and behold, we're going to get 6 over 0. Now, that cannot be a final answer. A lot of people want to do when they plug this back in and get 6 over 0, they want to just say does not exist, right? Because 6 over 0 is an undefined value. That is not a correct final answer, though. Anytime we get a number over 0, we have to do our left hand, right hand split. So that's where we have to go with this problem. So to the left of 0 would be if x equals negative 1. To the right of 0 would be if x equals positive 1. And we have to plug back in to our function. Now we can plug back into our simplified function. We don't have to go all the way back to the original. So we have 6 over 2x to the 4th. 6 over 2x to the 4th. Sorry, I'm just trying to write small. Okay, to the 4th. Now, if we plug in negative 1, okay, we're going to get 6. And 2 times negative 1 to the 4th power, negative 1 times negative 1 times negative 1 times negative 1 is positive 1. And if we plug in positive 1 to the 4th power, we also get 1. So, what's happening here? Oh, I forgot my negative here. That's why these should all be negative 6's. Sorry about that. So I'm going to get negative 6 divided by 2, which is negative 3. Negative 6 divided by 2, which is negative 3. Both of these are going down, down, down to negative infinity. That is my final answer there, not negative 3. Remember, anytime we have to do this left hand, right hand split, that means that my only three possible answers could be positive infinity, negative infinity, or does not exist. Those are the only three possibilities. But in this case, because the left side and the right side are going more negative, our answer is going to be negative infinity. Okay, going on. Part C. This one, again, is one of those where make sure you always plug in first. A lot of people will see this problem and just start factoring. Well, that numerator is not an easy one to factor. But it's not necessary, because if you plug in 0, well, 0 to the 4th power is 0. And 2x cubed is going to be 0. And negative 4x squared is going to be 0. And then we've got the plus 16. And then the denominator, 0 squared is 0, minus 4. We just end up with 16 over negative 4, which is negative 4. There was no reason at all to factor here. We simply plugged in and we got the answer that we needed. Part D, the limit as x approaches 5 of negative 10x. Again, always just plug in first. We get negative 10 times 5, which is negative 50. Boom, we got our answer. Moving on. Part E, this was kind of like that question on the homework where it was the limit as x approaches, I forget what the number was, maybe 3. And then it was a pi value here. Right, so we had the limit as x approaches pi. And for those who did reach out to me, we talked about how anytime that you have a constant here, that is always going to be your answer. Right, this is pretty much telling me that I have the function y equals 5. Well, no matter what x value I am at, then, if I kind of looked at the graph, this is y equals 5. No matter what x value I'm at, my y value is always going to be 5. So, shortcut here, if you have some sort of constant as your function, that is always going to be the answer to your limit problem. Okay, moving on to F. We've got the limit as x approaches 0. So, again, first thing we're going to do is plug in. And a lot of people wanted to give me 0 for this answer. 0 squared is 0. Negative 4 times 0 is going to be 0. But remember, anything to the 0 power is a 1, not 0. Okay, so we've got this problem overall simplifies to a 1, not 0. So just be careful with that. Anything to the 0 power is 1, not 0. Okay, moving on to our next problem, G. The limit as x approaches 3 of 2x over x minus 3. Well, if I plug in 3, I'm going to get 6 over 0. So that's my number over 0. So we have to do our left-hand, right-hand split. All right, to the left of 3 would be 2. To the right of 3 would be 4. And we are going to be plugging back into our initial function. All right, so over here we're going to get 4 over negative 1. That's a negative value, which means that the left side's going down. Over here, 2 times 4 over 4 minus 3. We are going to get 8 over 1, which is a positive number. That means that my right-hand side is going up to positive infinity. And since these two signs are different, that means that my overall limit does not exist. Okay? So if we're going to two different signs, the limit does not exist. Moving on to H. This is another one. Make sure you plug in first. Don't automatically try to start factoring. I mean, you can factor actually if you want here, but it's not necessary. When we plug in, all right, we've got 4 times 3 over 2 squared minus 9, and 2 times 3 over 2 plus 3. Now remember, when you square a fraction, you square both the numerator and the denominator. And over here, the 2 is over 1. So 2 times 3 over 2, those 2's are going to cancel. We're just going to be left with 3 over 3. Same thing here. This 4 is 4 over 1. So this 4 and the 4 in the numerator is going to cancel out. So I'm actually left with 9 minus 9 over 3 plus 3. So we get 0 over 6. Now this is just 0. Remember, if your 0 is in the numerator, okay, in the numerator, that's okay. Your answer is just 0. The only time it's an issue is when the 0 is in the denominator. That's when we have some sort of undefined value and we have to do either our factoring or our left-hand, right-hand split. But a 0 in the numerator is just 0. No reason to go any further. We have our answer. All right, question I. If I plug in 0, we're going to get 0 minus 0 over 0. All right, so when we get 0 over 0, we have to factor. The numerator, I have a common factor of x squared, so that's going to leave me with 5x squared minus 2. And in the denominator, we have an x squared being multiplied by a 3. So those x squareds can cancel. And now we are going to reevaluate our limit, again, of our simplified function. And when I plug in 0, we're going to get 0 minus 2 over 3. So negative 2/3 is our final answer. That's going to be our y value that we are approaching as our x value gets closer and closer to 0. Final question on the first page was simply the limit as x approaches negative 5 of x squared minus 5. Again, first thing is always plug in. Now, please remember, negative 5 squared is negative 5 times negative 5. That is not negative 25, that is positive 25. So we get 25 minus 25, which is 0. You can absolutely have 0 as your answer. Okay, no problem there. That brings us to the end of the first page. Let's move on to the second page. All right, guys, so now we are looking at the graph on the back page. Questions A, B, and C we're asking as the limit as x approaches negative 3. Well, here is negative 3. And the first thing that I noticed here is that I have this vertical asymptote. So anytime we have a vertical asymptote, your answer is either going to be positive infinity, negative infinity, or does not exist. Those are your only 3 options, because the vertical asymptote means that when you plugged into the function, you got a number over 0. So again, our only 3 options are positive infinity, negative infinity, or does not exist. So when I'm coming over here and looking for my answer, all right, part A says, as I'm approaching negative 3 from the left. Well, if I follow my function from the left, as I'm getting closer to negative 3, where is my function going? It is going up, 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 up to positive infinity. Okay, now part B. All right, as I'm approaching negative 3 from the right. Well, here's the right-hand side. As I approach from the right, where am I going? I'm going up, 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 also to positive infinity. And because the left-hand limit and the right-hand limit are the same value, that means that my overall limit is also positive infinity. Okay, so if both the left side, again, coming back, the left side and the right side are approaching the same thing up here, that means that my overall function is going to be positive infinity. Okay, let's move on to the next one. All right, so now we got D, E, and F. Now, D, E, and F are all kind of looking at the value of x equals negative 5. So again, D is saying I want to approach negative 5 from the left-hand side. Well, if I approach from the left-hand side, what y value am I approaching? Well, I'm approaching the y value here at 2. So that is my answer for D. Now, for E, I'm looking for as I approach negative 5 from the right. Now, again, I don't have to come all the way over here to the function. I just kind of have to come, sort of a couple of spaces over. So as I approach from the right, I am also approaching that same y value of 2. And again, because the left side and the right side are approaching the same value, my overall limit is also 2. Just remember, I don't need my overall limit to exist. Excuse me, I apologize. Let me backtrack. The limit can exist overall even if there's no point plotted, even if it's that open circle. The overall limit can still exist because I'm just looking at how I'm approaching from the left and the right-hand side. Am I approaching the same value? Which in this case, I am. All right, let's move on to the next ones. All right, now we've got G, H, and I, which are all dealing with as we approach the x value of 2. Well, here's the x value of 2. Now, first thing that I notice when I look at x equals 2 is that I have a jump discontinuity. All right, and a jump discontinuity, as you hopefully will have seen from the video from Monday, is that I have this change in level of my function. Okay, so I'm kind of coming along here, and then I literally have to pick up my paper, my pencil, and make this jump down to this other level to keep going with my function. All right, so first and foremost, anytime you see that jump discontinuity, your overall limit here is never going to exist. All right, so that should just be something in the back of your mind that because I see this jump here, my overall limit is never going to exist. So I know that this is going to be does not exist because of that jump. But let's go back and look at the left hand and the right hand to break it down a little bit further. All right, for question G, if I'm approaching 2 from the left, all right, as I get closer here, I'm now approaching x equals 2. What y value am I at? Well, I'm at this, whatever this y value is here, and that is at a y value of 1. Now, if I'm approaching 2 from the right-hand side, okay, that's this little part of the function down here. Right here's x equals 3, x equals 2.5, x equals 2.1. All right, I'm approaching this y value, which is at a y value of -1. And here's the big thing, because my left-hand limit and right-hand limit are not equal to each other, right? 1 does not equal -1. That is the reason why this overall limit does not exist. Okay, my overall limit doesn't exist if the left side and the right side are not approaching the same thing, all right? As we can see, because of the jump discontinuity that we had in that graph, okay? All right, let's move on to the final 3 questions. Now, the final 3 questions are no longer limit questions, all right? So it's no longer about where I'm approaching. This is now f of -5, f of 2, f of -3. This is pretty much saying when x equals -5, what is my y value, right? It's asking what is the coordinate of the plotted point. And remember, the plotted point is the closed circle. We are looking for a closed point here, not an open circle. All right, so if I'm looking for f of -5, I'm going to come over here to -5, and right there is that closed circle. That means that's the point that's actually plotted. All right, this open circle here means that you have something that's undefined at that spot. There is no point plotted there. So if you put 2 as your answer, you need to remember that an open circle means nothing is happening there. We need this closed circle, and that closed circle is happening at a y value of 1. So that is the answer for K. L is asking for f of 2. So that's asking us to come over here to x equals 2. Well, at x equals 2, I see an open circle here and an open circle here. I do not see any sort of closed point. I don't see anything on the graph that would be a plotted point at x equals 2. So that means that this is undefined. That's UND for undefined. Okay. Now, if you wrote does not exist there, I mean, it's all right, but really you don't talk about a point being that it does not exist. A point like f of 2 is undefined. All right. We talk about how a limit does not exist, but a point is undefined. All right. So any question like this where it's f of something, where you're looking for the point, if it's not there, you should be writing undefined, not does not exist. Does not exist, all right, refers to a limit. Undefined refers to a point. All right, those are 2 very different things. All right, and finally, M is f of -3. Well, here's -3. Again, I have a vertical asymptote at -3. Just by that fact, having a vertical asymptote, we know that an asymptote, you cannot touch this line. Therefore, no point can be plotted on that line. All right, so again, f of negative 3 is also undefined. There is no point plotted anywhere in that spot at that x value. Okay, well, that brings us to the end of that mixed limits practice sheet. Hopefully this was helpful, and please just let me know if anybody has any follow-up questions about anything. All right, thank you.